This lesson is a continuation of section 2.4, solving with variables on both sides. This lesson deals with your special cases. So when we have variables on both sides, sometimes special cases arise. So I want you guys to take a second to work the first two problems. If you need to, pause the video and then we'll talk about those. So hopefully, whenever you simplify down the first problem, you ended up distributing and then combining like terms, and you should have gotten something like this. 5h minus 7 equals 5h minus 7. So if you follow your steps at this point, the next thing would be to get the variables to one side. So let's move the 5h with the other 5h. Remember, you need to move the entire 5h, not just the h, so you need to subtract 5h to both sides. 5h minus 5h is just 0, so I'm left with negative 7. 5h minus 5h is also 0, bring down to minus 7. Now I need to get my constants to one side, so I'll add 7. I get 0 equals 0. This is a special case, and we'll talk about this case in a second. I want to go over the next example so you have a comparison. So the first thing you should have done in the second problem is distribute the 2. 2 times n is 2n, 2 times 1 is 2. Combine your 5 and your 2 over here. You get 2n plus 7 equals 2n. Okay? Following your steps, the next thing to do is to get the variables together. So let's subtract 2n from this side over here. 2n minus 2n is just 7. 2n minus 2n is 0. These are your two special cases. Whenever you have a scenario where your variables cancel out, notice here we don't have n equals a number. Over here we don't have h equals a number. The variables disappear, they're gone. That should be a red flag that this is going to be a special case. Take a second to look at your first problem, and I want you to draw your attention to this step right here. Take a second to think about what values you could replace h with to make that a true statement. So think about if you were saying h equals 3, and you were at the step where you're going to check your work to make sure it makes sense. What values could you plug in for h? Hopefully you guys are noticing that both sides of the equal sign have the same expression. 5h minus 7 on the left side, we also have 5h minus 7 on the right side. So if we let h equal 0, we'll get negative 7 equals negative 7. Is that a true statement? It is. If you let h equal 1, you'll get 5 minus 7 equals 5 minus 7. Are those two expressions equal? Yeah, 5 minus 7 is negative 2, so we'll get negative 2 equals negative 2. If you have h equal to 2, you'll have 10 minus 7 equals 10 minus 7. 10 minus 7 is 3, so you'll have 3 equals 3. Because the expressions on both sides of the equal sign are the exact same, you could plug any number in the world in for h. 100, 2 million, a half, 3/4, negative 2/4, whatever it may be, and it's always going to work. So anytime you are solving and you notice that, hey, the left-hand side is the exact same as the right-hand side, that's going to produce an answer of all real numbers. And what that means is you can plug in any number in the world in for h, and it's going to work. So every number satisfies that equation. That's a special case. Whoops. Look at the second problem. I want you to focus on this line right here. Okay? Notice that it's not equal like my last one. I have 2n plus 7 equals 2n. I need a plus 7 for it to produce in all real numbers. case. But I don't have that plus 7. But notice that the coefficient next to the variable are the same. I have a 2 in here and a 2 in there. Okay? That should send a red flag up. Because whenever you try to move those together, they're going to cancel out because they're equal. And because they're not the same, when they cancel out, we're going to be left with something like 7 equals 0, which doesn't make sense because 7 is not the same as 0. So, once again, take a second and start plugging in numbers that could possibly work for n. If n equals 1, we'll have 2 plus 7 equals 2. 2 plus 7 is 9. Does 9 equal 2? No. So that's not going to work. If I let n equal 0, I'll have 7 equals 0, which that doesn't work. If I have n equals 3, I'll have, 6 plus 7 equals 6. Well, 6 plus 7 is 13. 13 definitely is not the same as 6. So you can see where this trend will continue. So if you start solving and your variables cancel out and you're left with a statement that does not make sense like this, 7 equals 0 or 15 equals 18, negative 6 equals 30. If you're left with anything like that where you're like, that doesn't make sense, your answer is no solution. And what that means is you can try your best to find a number, but no number will work for that situation. There's not a number that will satisfy this equation. This is just an equation that does not have a solution. Okay? Those are your two special cases. So take a second and pause the video, and I want you to try to work these on your own. Make sure you understand why the answer is the way it is. See if you can identify the step that led you to figure out that these were no solution in all real numbers cases. Okay, that's the important part. I want to make sure you understand why any number will work for the equation, or why no number will work for the equation. If you're struggling with this topic, make sure you come and talk to me, okay? So did you meet the objective? So like I said, this lesson was a continuation of the first part of the lesson. So our objective, remember, was to be able to solve an equation that contains variables on both sides of the equal sign. So here's your two problems I want you to try out to see if you really grasp the concept. Your answer should be negative 5/4 in all real numbers. Please, if this is something that you are unsure about, you can try to rewatch the video. And if you're still unsure, please make sure you come see me for help.